you said you were getting stuck on. So on question number 3, a shipping container is in the shape of a right rectangular prism with a length of 12 feet, a width of 4 feet, and a height of 8.5 feet. The container is filled with 102 cubic feet of water. What percent of the container is empty? So the first thing I just want to point out, just one little thing, that when you see anywhere if a problem references a right rectangular prism, that just means that it's a box. Okay, so that's just a fancy way of saying box, so I don't want that to throw you off. Now let's go over to the diagram and we're going to just label what they told us. So they said that the length is 12, the width is 4, and the height is 8.5. So 12, 4, and 8.5. Okay, so to do this problem, what we're going to first do is just find the volume of this entire container. Okay, so from our formulas for volume, and this formula you do get on your reference sheet, so you don't need to memorize it. Volume is equal to base area times height. So the uppercase B always stands for base area. Now in this example, it's a rectangular prism, meaning that the base is in the shape of a rectangle. So to get the area of a rectangle, we're just doing length times width. So if we're just looking at the base now, we're looking just at the 12 and the 4. So 12 times 4 gives us 48. Okay, so now let me plug that back into our formula. So the volume is equal to, we know the base area is 48, and we know the height is 8.5. And when you multiply those together, you get 408. So 408 cubic feet. So that's the volume of the entire container. So this question says the container is filled with 102 cubic feet of water. What percent is empty? So if I want to find the percent that's empty, let's first find the amount of the container that's empty. So if 102 cubic feet are being used of the 408, I'm just going to subtract the 102. And when I do that, I get 306. So what this means right now is that 306 cubic feet are empty. Okay, so this is the amount of the box that's empty. So now to get the percent, so we're going to do the 306 divided by the total amount of the container, which was 408. And if you do that in your calculator, you're going to get 0.75. And then to convert this into a percent, you just scoot the decimal point over 2 spaces to the right. So we end up with 75%. So 75% of the container is empty. Okay? All right, so that was question number 3. Now another option could have been that you could have found the amount of the container that was filled and then just subtracted from 100. That would have worked. Okay? All right, so let's look at questions 4 and 5. So for question 4, new streetlights will be installed along the town of Belmore. The posts for the streetlights will be 750 centimeters tall and made of aluminum. The town chose rectangular prism posts that have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 40 centimeters on each side. Determine how many cubic centimeters of aluminum is needed for each streetlight post. Okay, so there's a lot going on in this problem. So what we have here is a post thing that's hollow in the middle. And we just want to find out how much aluminum do we need to make this, considering that the inside of it is hollow. So the first thing we're going to do is let's just get the volume of the entire thing. Okay? So just like in the last problem, hang on. Volume is equal to base area times height. Now the base here is a square, and to get the area of that, we just do length times width. So in this case, you're doing 40 times 40. That gets you the base area, and then the height is 750. Okay, and when you multiply those 3 numbers together, you get 1,200,000. So the volume is 1,200,000. I know that seems big, but just keep in mind the units here are centimeters. So that's why it's going to end up being big numbers. So this is centimeters cubed. Okay. All right. Now I'm going to find the volume of the inner part, the empty part that is inside of the post. So an important part for this question is to notice here the aluminum is 2.5 centimeters thick. So what that means is that looking over here, if one side is 40 centimeters and my aluminum has a thickness of 2.5 on each side of that, and I want to figure out what the length would be just on the inside part, so not counting those outside pieces. So what I'm going to do is do my 40 and minus the 2.5 over here and minus the 2.5 over here. And that gets me 35. So that 35 is the length of the hollow part on the inside, which is going to also be the same as the width because it's a square. So now I'm going to get the volume of the inside part. So that is going to be base area times height. The base again is a square, so it'll be 35 times 750. And when you type that in your calculator, you should get 918,750 centimeters cubed. So the second part that we did, the 918,750, that's the portion that's not going to be a part of the actual post because it's hollow. So then to figure out the volume of the aluminum, so just the part that is actually being built, you're going to subtract these two numbers, okay? So when you subtract them, you should get 281,250 centimeters cubed. So 250 centimeters cubed. Okay. So I know that's definitely a little confusing because you have to, figure out like the inside length by subtracting off the edges. So I know that's a little confusing. So now down for part B, the aluminum weighs 2.7 grams per cubic centimeter. In grams, how much will 6 streetlight posts weigh? Okay, so we know again the volume is 281,250 cubic centimeters, and if it weighs 2.7 grams per cubic centimeter, we're going to just take that 281,250 and times it by the 2.7. And when we do that, you should get 759,375. So that is the weight of one lamppost. A lamppost? Yeah, street lamppost. So if I want the weight of 6 of them, I'm just going to times this by 6. And I end up with 4 million. Oops, hang on. That looks crappy. Okay. 4,556,250 grams. So I know it seems like a lot, but just keep in mind the units here are small, okay? We're talking about having the answer in a small unit. So that's why the number is going to be kind of bigger than what you would expect, okay? All right. And now the last one, number 5. So we want to find the volume of the house below to the nearest hundredth. Okay, so in an example like this, what you really need to do is break it into 2 different problems, okay? So what we're going to start off by doing is just focus on, let's get the volume of the top of the house, or kind of like the roof part, okay? So the top part, that's a triangular prism, okay? So right now I'm going to just do the volume of the top. Now, it's still going to have the same formula, base area times height, because it's still a prism. But just keep in mind here that the bases in this example, just looking right now at the roof, are actually these 2 triangles, because the The bases are the pieces that are going to be parallel to one another. Okay, if we're talking about a prism, you need to have congruent bases. So we need to get the area then of the triangle that's the base. So the formula for area of a triangle is 1/2 base times height, little base. So just keep in mind, looking at the picture, that if this is 17 down here, this is also going to be 17 up here. So we're doing 1/2 17 times 7, because they gave us the height over here. And when you type that in your calculator, you should get 59.5. Okay, so now let's go back and plug that into our formula. So the volume of the top, we're doing the base area. So 59.5 times the height. Now when we're talking about prisms, the height is the distance between the bases. So how far apart the bases are. So if this is 12 down here, this is going to be 12 up here. So times 12, and that gives us 714 cubic meters. Okay, so this is just the volume of the top part of the house. Now we need to get the volume of the bottom part here. Okay, and this is a rectangular prism, so volume of the bottom is equal to base area times height. Now the base in this example is a rectangle, and our formula for area of a rectangle is length times width. So we're starting with doing 17 times 12, and then we're going to multiply that by the height, which is 10. Okay, and when you multiply that, you will get 2,040 cubic meters. Okay, so now that you have the volumes of the two pieces, now the final step is just add them up. You just have to add the two numbers together. So you're going to add the volume of the top part, the triangular prism, with the volume of the bottom part, the rectangular prism. So we get 714 plus 2,040, and we end up with 2,754 cubic meters. Okay, and that is our answer. Okay? All right, so if you still have questions after this, send me a message, and we can always do a Zoom session and go over more questions in depth if you're still having trouble. Okay? All right, thanks.